Alright, so right now we're going to discuss about the reactions of carboxylic acids. Now these reactions, I'm going to write the general scheme of it first. So the reactions involving, there's the reactions involving the hydroxyl group, the hydrogen atom. So as we know that the carboxyl group looks like this. Now if we see that this is the carboxyl group, this is the hydrogen group, and this is the hydroxyl group. So the reaction involving the hydrogen, this is going to get removed. So in this we may see the reaction with metal, bicarbonate and metal carbonate, and we may see the reaction with a base. And then what we have is reactions involving the hydroxyl group. So what we'll see over here is the dehydration reaction, which may form the acid anhydride, and then we'll see Fischer esterification, which involves the reaction of carboxylic acid with alcohol, and then we will see the reaction with thionyl chloride, which we may write it as PCl5, which is phosphorus pentachloride, and thionyl chloride or thionyl chloride, or we may also use and then we may see the reaction with ammonia. Alright, so these are the 4 reactions, and then so this is the reaction involving hydroxyl group, which is present over here, and then we may see the reactions involving the whole carboxyl group, which we have the reduction which are partial reduction and complete reduction. And then what we also have is the didistillation of calcium salt of carboxylic acids. And what we have also is the reaction with soda lime, which is calcium oxide with sodium hydroxide in the presence of heat. Alright, so let me just see. Alright, so we may start out with the reaction involving H group, which is present over here. So the reaction involving H group, first we'll react it with a metal. So metals from the 1A group or the 2A group. What we see is the effervescence of hydrogen as gas. So what we have over here is we can use sodium, potassium or magnesium. So let's just use magnesium. And then we have, for example, acetic acid. So the H group is going to remove, and then we will have salt of carboxylic acid, which is actually that's magnesium. So that's going to be magnesium acetate, which is salt of carboxylic acid with the evolution of H2 gas. Now the next is the reaction with metal carbonate, which is metal carbonate, which is Na2CO3, and metal bicarbonate, which is NaSCO3. Now the same byproducts are going to form, which is carbonic acid. This carbonic acid is going to break down into water and carbon dioxide. Now this is going to show a bubbly effervescence of carbon dioxide, which will show that the reaction has occurred, and which will actually show the acidity of the carboxylic group. And so if we see that we use the metal carbonate or metal bicarbonate with the carboxylic acid, we form the same sort of carboxylic acid with the byproducts. Now moving on, we may see the reaction with the base, which is sodium hydroxide, which is going to follow a double displacement reaction. It's going to form acid, and the base is going to react with together and then form salt and water. This is a salt and this is a water. Now if we see that a simple reaction of a strong acid and a strong base, it results in a neutral salt. So this is a double displacement reaction, which is a neutralization reaction. In this neutralization reaction, a neutral salt is formed, so the pH is not going to change from. So for the neutralization, the heat of reaction, the standard heat of reaction is minus 57.4 kilojoule per mole. Now for this particular reaction, we have a weak acid and a strong base is going to form a basic salt with the removal of water. So now this basic salt, what it's going to do is this standard, which is set over here, it's going to reduce it in magnitude. So the heat of reaction is going to be like minus 55 or anything like that. So this reduction means that this will partially ionize. So this will, for example, this will completely favor in the 99% in the forward direction and 1% in the backward direction. Now this will partially ionize, meaning it will favor the backward reaction more. So what we have over here is an exothermic reaction showing the negative sign. So all neutralization reactions are exothermic reactions. So this is addition. So what we have over here is the enthalpy of neutralization. Note this value. So now moving on, we have seen all this. Now we move on to the reaction involving the hydroxyl group. Right, so first we may see the dehydration reaction, which may result in acid anhydride. General formula of acid anhydride is RC double bond O O C double bond O R. Dehydration reaction and dehydration reagent is phosphorus pentoxide. So if we have, for example, two carboxylic acids, I'll flip the configuration. So what's going to do is, it's going to take this is a reaction involving the hydroxyl group of one molecule and the hydrogen group of another molecule of carboxylic acid. It's going to form the corresponding acetic anhydride in the presence of phosphorus pentoxide. So now we may see the Fischer esterification. In Fischer esterification, alcohol and carboxylic acid react to form the corresponding ester with the removal of water. So what's going to happen is, for example, an alkyl ester is alkyl alkanoate. So we have an ethanol over here, and then we may take butanoic acid. So we have the butanoic acid. So it will form. So what it's going to do is, it's going to take up this part, it's going to take up this part. So what will form is, so this part is going to be alkyl, and this part is going to be alkanoate. So this is going to be ethyl butanoate. So now moving on, we may see the reaction with cyanide chloride, which is SOCl2. Now this will produce a acid halide, which is like this, and this is going to be in the purest form. So the reactant involving this, and then it's going to react in the presence of pyridine, which looks like this. So if we take with the cyanide chloride molecule, what will form is a corresponding acid halide, which is acetic ethanoyl chloride with the removal of HCl. So hydroxyl group is going to remove, and then the Cl group is going to attach itself to that. Then moving on, we have the reaction with ammonia, which is NH3. What's going to happen is, if we take carboxylic acid with ammonia, it's going to take up the hydrogen and the hydroxyl group, and then it's going to form ammonium acetate ion. Now this is going to heat itself up, and then it's going to form an amide, which is acid amide. So now we're going to see the reaction involving the carboxyl group. So we may see the reduction first. So if we see that partial reduction takes place through lithium aluminum hydride. Now lithium aluminum hydride is a strong reducing agent, and carboxylic groups are less reactive towards reducing agents. Like aldehydes are the most reactive to reducing agents. Like it's going to react with sodium borohydride, which is a weaker reducing agent than lithium aluminum hydride, because it's strongly available to nucleophiles to the reducing agents due to the presence of less bulky groups, and for example, the acetone or ketone is going to react with lithium aluminum hydride only because it's got bulky groups attached to it, attached to the carbonyl carbon. So that's why carboxylic groups show partial reduction. So if we see that we react with the lithium aluminum hydride and then we reduce it and then we form an alcohol. So what we form here is an alcohol, which is acetic acid. It's going to form ethanol, which is also called as ethanoic acid. Ethanoic acid is going to ethanol. Propanoic acid is going to form propanoic acid. So it's going to form only 1 degree alcohols. So moving on, we may see the complete reduction also. Complete reduction has hydrogen iodide in the presence of red phosphorus, and it's going to form alkanes. So what we have is hydrogen iodide and phosphorus. It's going to remove the whole carboxyl group. So what's going to form is ethane for ethanoic acid, and then it's going to remove water with it, and it's going to form iodine gas also. So this is the reactions. So if we see the dry distillation of calcium salts of carboxylic acid, what we're essentially doing is, for example, if we have this molecule over here, which is calcium salt of acetic acid and formic acid. So what's going to do is we're going to heat it up, meaning we're going to do dry distillation. What's going to happen is this calcium carbonate is going to get removed. So it has 3 carbons and it's going to get removed as CaCO3. And then what we're going to form from here, we're going to take the hydrogen and then we're going to take this, and then we're going to form something called as acetaldehyde. We can also form alkene with it. Actually, we can also form ketone with it. I'll show you. We'll just replace the hydrogen with an alkyl group. So this is going to get removed as CaCO3, and dry distillation is going to occur, and then we form a ketone from here. And then we see the decarboxylation of carboxylic acid. So if we have a carboxylic acid, for example this, and we react it with soda lime, the presence of heat, what's going to happen is this structure is going to get removed. So what we'll have is, so this is going to get combined with this, and then we're going to form the corresponding alkane, which is methane. For example, if we have propanoic acid, it's going to react with calcium oxide with sodium hydroxide, which is soda lime.